as it is transforming the human race, on the other side, there is a huge gap or huge challenge that it's going to pose against the human race. Dave Waters says that in a few years, AI virtual assistants will be as common as the smartphone. Maybe 5-6 years back, had I told you this, you would have laughed at me for sure. But look at it today. I can tell you one thing for sure. At your home today, more than the number of people in your family, you have more number of AI agents. Have you realized that? That's the kind of transformation that's happening around us. That's the kind of AI evolution or revolution that's happening around us. So I would like to finish it with one quote from the legend, Andrew Ng. Do you all know who is Andrew Ng? Any guesses? Let's see who guesses this right first. Ex-Googler, okay. AI expert, founder of Google Brain, okay. Coursera is the primary connection, isn't it? He's the father of modern day machine learning. Yes, I agree. So he says that AI is the new electricity. This is a very, very interesting perspective, because why does he need to compare AI with electricity? There are very few innovations that have happened in the human race which have actually changed the way the humans think, act, and behave. And definitely AI is one of them. So just like the fire, wheel, then electricity, internet. I mean, maybe 20 years back, if somebody had told you like we can sit in our own homes and we can get a degree online without going to the college, we might not have believed it. Look, today we're all sitting in different places in remote workplaces, and still we are able to connect over internet, isn't it? It has transformed the way we are thinking and we are operating. Same way, AI is going to transform our thinking in the coming days, and it has already started doing so, by the way. I don't know how many of you have Alexa at home and how your kids are doing their homework. I have a 4-year-old in my house, my daughter. She talks to Alexa continuously and she practices ABCD along with Alexa. That's the kind of friend she has found in Alexa, which is an AI agent, isn't it? So this gives the context for us to understand what AI or why AI is very powerful for all of us. So maybe I'll start with a basic question. What differentiates a machine from a human? To understand to give you a brief introduction about AI. Can you tell me what is the difference between a machine and a human? What do you think? Feelings? Okay. Emotions? Judgment? Consciousness? Brain? Machine is a programmed device. Okay. Intelligence? Very good, Venkat. Ability to take decisions, decision making. Okay. Good. Wisdom. So intelligence is one word I would like to pick it up, because today we are talking about intelligence, isn't it? And of course, that's a related word. So when we talk about intelligence, that's one key differentiator between a human and a machine. Of course, emotions, all the other aspects that we are talking about is a reflection of intelligence, isn't it? We can call it as emotional intelligence in other aspects. Now, to help you understand, broadly speaking, intelligence can be divided into 5 different dimensions: reasoning, learning, perception, problem solving, and linguistic intelligence. You all know what is reasoning. Why behind what, isn't it? If I'm able to decode why certain events are happening, like why you are attending this webinar, let's say, for example, if I'm able to decode this, that means I have intelligence to reason things out. Learning. Can I learn from my past mistakes? Can I understand something new from the data that is available to me? From any experience that I've got, can I learn something? If I'm able to do so, that means I am learning. The third one is perception, which is always a complicated one. Not everyone guesses this right. Even though in English, the term perception carries different meanings. But actually speaking, perception is how do we perceive the environment? God has given us 5 senses, isn't it? The cognitive senses, what we call it as. By the way, how many senses we have? 5 or 6? 6, 5, usual confusion, isn't it? The class is always having a split, no doubt. So yeah, of course, we have 6 senses. The 6th one is called as a common sense or the intuition. The fifth one, the five senses are nothing but the cognitive senses, what we call it as. The cognitive senses are given to the human being so that the human being is able to understand what is happening in the environment with the help of the five senses, and is able to make a perception in the mind with the help of cognitive functions, abilities like thinking. He is able to understand, he or she is able to understand what is happening around the environment, and that's what is perception. Problem solving, we all know, like anyone who is good in mathematics is supposed to be intelligent, isn't it? Right from the school days, we have been used to train to think in that direction. And fifth one is linguistic intelligence, the most underrated form of intelligence. That is, we all have this ability to understand the language in any form that I speak to. I'm speaking English, but my accent is different, my pronunciation is different, the choice of words is different, but still you're all able to decode to an extent, isn't it? Sometimes I watch a Korean movie. I'm sure some of you will be Korean movie fans, right? We may not know Korean, but still we're able to decode, understand the context, isn't it? We have that intelligence in our minds, brains, which are able to help us decode the language to an extent. So that's also a form of intelligence. So if I have to define AI, now just to set the context for our discussions further, it is all about the two words, artificial and intelligence. Intelligence is nothing but the five dimensions that we just spoke about. So this one is not available with the machine normally. So we are giving all these elements, the five dimensions or one of these dimensions, to a machine, and we are making that machine intelligent. That's what is AI. So an AI can reason things out. A machine, if it can reason things out, you can call it as AI. A machine that can see, you can call it as AI. A machine that can hear and decode, you can call it as AI. A machine that can learn, you can call it as AI. So that's how you define artificial intelligence. That is intelligence, the different dimensions given to a machine artificially. So now let's look at the broader areas of AI, and then we'll get on to understand why it is creating the paradigm shift. Look at the aspects here. Machine learning, that is, if I am able to give the power of learning, decoding how a person learns, how a human learns, and then I'm able to give it to a machine, I call that machine as machine learning. That is, normally machines are not intelligent, correct? Machines do not learn. Take calculator. Calculator is a machine. Do you think calculator is intelligent, even though it is solving problems for you? Calculator is not intelligent, right? Then calculator, does it learn, by the way? It does not learn, right? Press a press button. Yes, you are going to add two numbers, whatever that is passed across, irrespective of what numbers you sent across. There is no change in the logic. So machine learning is the ability of the machine to learn over a period of time from the data that is fed across. The power of learning of a human being, I'm able to decode and give it to a machine. That's what is called as the machine learning. Now take natural language processing. What does it talk about? NLP is nothing. What is the dimension of intelligence I am trying to decode and encode here from humans to machine? Can you make a guess? When I talk about NLP, can you connect with one of the dimensions of intelligence that I spoke about? Like reasoning, learning, perception, problem solving, linguistic intelligence. Linguistic, yes. So here what we are trying to do is, as Mahatha is saying, natural language processing, in simple terms, I can put it out like text analytics. Simple terms. Text analytics means, can I decode what is the knowledge that is residing in the text? I'll give you a simple example, speech. I'll connect the speech and the NLP together and then give you this example. Take our voice assistants like Alexa, Siri, OK, Google, all these aspects. How does it work? When I talk to Alexa, Alexa is first trying to understand what I am speaking. It is converting the speech to text, first of all. Then the text is given to the NLP algorithm. So there are a set of algorithms which is helping the conversion of speech to text. And then once it is done, the text is analyzed using NLP techniques. where we try to decode what is happening and understand the knowledge residing in that text. So that's where all these subsections come into picture: classification, clustering, information extraction, everything. Use multiple techniques to do that. And once it is understood, like, oh, Lakshmi is asking for time in Bangalore, then Alexa connects with the search engine, the knowledge repository, gets the answer for the time, converts the text to speech again, and then gives back the response. So NLP as well as speech are also forms of AI. Are you with me so far? Do you have any questions? Understandable so far? Perfect, good. Let's slowly. Okay, Pankaj is asking, what about context? Context is important, no doubt about it. Context is what is going to help you to understand things in a better way, right? Like there, I mean, I saw a famous image, a tiger versus a dog with tiger stripes. How will I know the difference between the two? As a human, I can understand that, okay, this is not a tiger. It's a dog with tiger stripes because I know the context. But if I give both the images to a machine, which usually comes under computer vision, without the contextual data, the machine cannot understand which one is a dog with stripes and which one is a tiger, isn't it? So context is very, very important. So that's where whenever we talk about AI or machine learning or all these aspects, data is what is the key. Analytics is the solution, the technology behind. So the speech to text, text to speech, NLP, computer vision, all these aspects, if you notice, we are all using data. We crunch data, we analyze the data, and then we are able to use the data for better solutioning. Okay, somebody says that I'm not audible. Am I audible to everyone? Sorry for the quick check. Okay, perfect. Let me continue. Yeah. So you have understood speech. The fourth one is the second era of AI, what we call it as expert systems. Have you seen Hollywood movies where the Air Force One is attacked by a missile? Now, who is the best person to man over the flight? Is it human or the autopilot, the machine? If the Air Force One is attacked by a missile, what do you think? Machine? Human? Human? It's all the Sully effect. Okay, human brain. Okay, but tell me one thing. What if you have just imagine you are a human with emotions. If I put a gun in your head and ask you to take a decision, do you think you'll be able to decide it right? Most probably not, right? Especially when the missile is coming behind you. You are the pilot. Don't you think you'll be scared a bit, even though you're trained for such situations like Air Force pilots and others? Now think about it, a machine without an emotion, which has the ability to control the flight, which can take all the data and cheat the missile which is coming behind also. Can't it make a difference? So that's an example for expert system. The expertise of the pilot is fed across into a machine in the form of an algorithm. And then we are making that machine intelligent. Make sense? So that's what we call it as expert systems. Planning, scheduling, optimization is a very popular one in manufacturing space generally. It's typical complex problem solving. Any complex problem, how can you split it into smaller ones and how can you make it work? That's what this one is. Robotics is the famous one. I'm sure all of you would have known this. The face of AI is robotics, the humanoid bots, which is a combination of all dimensions of intelligence in a way. It is able to see, think, hear, and everything. It is able to learn. It is able to reason things out. Okay, so those are examples of robotics. Lena, I just gave an example for expert system. One is autopilot, which is an example for expert system. The expertise of the pilot is fed into the machine. The other one is underwriting system. And in fact, most of the softwares that we are using today Your mobile and everything is all intelligent in a way, right? Just that the intelligence is fed into the machine in the form of coding, in the form of algorithm. Correct? All machines are intelligent today, if you notice. Just that the way the intelligence is fed into the system is different. Okay, good. Take computer vision, the last example, last area that is explored in AI. Computer vision is nothing but taking the power of perception. That is how humans can see. Can I decode and can I capture images through the camera and decode that complete images and everything into a kind of a system, and then able to understand what is there on those images. If I'm able to understand that, that's called as computer vision. So we'll look at some examples. I'm going to discuss about autonomous car in the next 5 to 10 minutes. We'll understand more about it. So IBM Deep Blue that defeated Gary Kasparov. Yeah, in fact, the old machines that were used across for winning computer games, the chess, go-go, and everything, initially in 90s, we can call them as expert systems because the rules of the game were clearly defined, and we were all playing within the rules of the game. But today, making the machine intelligent, we have an alternate way where today when we are winning the games against the humans, against the grandmasters, actually machines are picking up a different technique to learn. Okay, so there comes the difference. In fact, I'm sure you would have learned about deep learning or deep mind. Have you heard of this company, Deep Mind, which was acquired by Google? If not, just note it down and read about it. This one is working on deep learning as a concept. Okay, so that deep learning is something which is helping the machines to decode a bit, understand how the grandmaster is playing, look at the moves, and it is able to learn by itself how to beat the grandmaster. Yes, Kamal, today it is deep learning using reinforcement learning. Okay. Society, just Google for Google DeepMind. I think that should work out. Okay, good. Now you have understood what is AI. I have given you the context. Now let me get on to the aspect of what makes AI special today. Because suddenly if you notice, by the way, I will ask a simple question maybe before I get to the concept here. How old is artificial intelligence? Can anyone make a guess? Kamal says 1956, 50 years old, Upendra. Padma says 1950, 50 years, 60 years, 20 years, 91. Okay, good. Lot of interesting answers. But I think Kamal started it right, 1956. In fact, before that also, there was a bit of AI that was happening. So Kamal says the Dartmouth conference, he's giving the specific reference. Absolutely right, Kamal. So 1955-56, that's when in the Dartmouth conference, people discussed about coining the term artificial intelligence and creating intelligent machines. But the funny thing is, even before that, in the Third World War, the Second World War, end of the Second World War, 1940, late 1940s, if you notice, Alan Turing, as Kamal is saying, the Alan Turing test. Have you heard of this Turing test? Can machines think? She started, exploring that. So Alan Turing is a famous test that happened. So read about that. That's when the AI started. But look at it this way. If it is old for 55, 65 years, roughly, why do you think we are talking about AI so much now? In fact, I remember 20 years back in engineering, I was studying neural systems, which is also the base for deep learning today. But suddenly in the last 10 years, we are talking about AI much. Can you guess why? Technology was not as developed as it is now. Okay, good. Data plus computing power, very good. Computational power, yes, absolutely right. Data, yes. So just to quickly give you the answers, big data is one big change that has happened. Processing power has increased very much. Open source systems, that's one thing which has made a big difference, right? Which has resulted in languages, as Chetna is pointing out, like Python, R. We're able to play around with a lot of things. And thanks to internet, which has resulted in cloud, as Upender is saying, Cloud has brought in a lot of difference. The computational power is provided, the storage power is provided, which can help us to process huge volumes of data with advanced techniques. So in a way, all these technologies have come together at the same time, which has resulted in the golden era of artificial intelligence, which is machine learning. Now, this machine learning is what is making AI special in this era, in the last 1 decade. Now, what is special here? This is where the paradigm shift is happening. Let's understand this basics. As I was telling you, machines were carrying intelligence before also. How did they carry? We were building algorithms into machines. How those algorithms were built in? Like using if-else logic. We were writing long programs, like everything has to be coded into the machine. And this was called as a traditional programming style. Like you write a program and you pass data. If you're done programming during the school, college days, if you're not coming from the IT world, most probably you may connect to this. We will write functions or programs where we'll pass inputs and we'll get outputs, correct? The logic will be written by us. The logic will be either some formula, something we'll write it in between. So data is passed, substituted in that formula, the answer comes out as outcome. Now, come to the modern day machine learning style of programming. What is happening in the machine learning? Unlike the traditional programming where you are saying that I will feed in intelligence with the help of programming logic into it directly, I'll give the machine, in the modern day world, I'll give the machine the data. Let the machine learn from the data. I will just tell the machine how to learn, what to learn. Let it learn by itself. So that's what is called as a machine learning. An important factor, I will tell you the big difference that has happened now. Do you know one power of human intelligence which was not available with the machines earlier? The power of pattern recognitions, which machines did not have. Do you know that humans learn a lot of things through patterns? Do you agree with me? Like, for example, take my case. I am talking to you now. You are hearing my voice. Maybe after 2 days or after 2 months, accidentally we are meeting somewhere. If you hear my voice, immediately it recognizes your the brain will start looking at the patterns. Oh, I have heard this voice somewhere. Oh, I think this person is this. So you're able to connect the pattern to the new data that is coming in, and you're able to recognize and you're matching the pattern. I'll give you one more example. If I show you a new dog, you'll be able to recognize that as a dog, even though you're seeing my dog for the first time. How? Simple. Dog has certain features, and right from the school days, somebody has told you how those patterns have emerged over a period of time. And from those patterns, you're able to capture it like, oh, this is how the dog will look. And somebody has told you it's a dog. So in your mind, that pattern is labeled as a dog. Now, any dog I'm showing it across to you, you're able to quickly connect and say that, oh, yes, this is a dog. In fact, this is the reason I always say this. How many of you have watched Game of Thrones? What is that pet animal which comes in Game of Thrones? The Stark family will have a pet, right, with everyone. What is it called? Wolf. Can you be specific? Dire wolf, right? Not the dragon. The Stark family will not have the dragon, right? It's a wolf, dire wolf. But were you able to recognize it in the very first time that it's a wolf? I got confused it with Alsatian dog to begin with, because I have not seen a dire wolf in my life. My mind is trained only for a specific set of data in Bangalore, in Tamil Nadu, in India. That's all. Dire wolf, I don't think it exists in India, correct? Suddenly, when I'm seeing a new animal, which I do not know, which was not taught in the school textbooks, or which I have not seen, I am bound to make a wrong guess. Do you understand what I'm trying to say? This is called pattern recognition. There is no pattern that is existing for me, which is matching to the new animal that I'm seeing in Game of Thrones. So this power of human intelligence in the name of pattern recognition was not given to the machines for a long time. Now today, in the name of machine learning, I am telling the machine that, look, boss, I will give you the power of recognizing patterns. How? I'll give you all the data. Use statistical algorithms. Try to decode those patterns. And then try to put across what patterns you have recognized. Try to use that and capture it in the form of a mathematical equation, or what we call it as a model, and use that model for predicting the future. This is what is happening in machine learning. So Chetna is asking, red light is considered as stop. Is it pattern? Yes, absolutely right. Tomorrow when somebody shows red, won't you stop? We are coded, right? We are coded over a period of time. There is a pattern that is there in our mind. Red means stop, green means go. Correct? That's the beauty. Now, the whole machine learning is about decoding, understanding the patterns from the past data. Just like the humans are learning from the past experiences, machines are going to decode the logic from the data and build its own logic over a period of time from the past data. So you may be surprised. Okay, what is happening? I mean, it's okay. Like, we are able to build logic from the data, but what is surprising here? But this whole logic, are you able to understand it first place? How machine learning works? Do you want me to give one more example for you to understand this better? Okay, I'll do that. Okay, let me take this example. If again, dog and cat, we always love those examples, isn't it? I want to give you two images, cat and dog. Okay. If I ask you to identify which one is a cat, which one is a dog, will you be able to identify easily by writing a program using traditional programming? We can't do it, right? Even though we may say that, okay, height, based on the height, I can say cat and not a dog, all these things, but there are a lot of exceptions, isn't it? Too many exceptions. Absolutely right, Ashok. Now, the best way to do it is, I will give the machine 10,000 images of cat from different styles of photo, and then say that, look, boss, from these images, can you find a pattern? And can you put it in the form of a model? Now, all those 10,000 images, can I put it in the form of a pattern? Yes, I can decode and put it in the form of a pattern, captured in the form of a model. Now, when I show a new image of cat, whether this image matches this pattern or not, that has been captured. So that can be identified with the help of the mathematical equation. This is what we call it as prediction. So in machine learning, we are using the past data, which has the corresponding labels, like 10,000 images of cat, every data labeled as cat. I'm capturing everything, and I'm decoding it with the help of statistical models to create a machine learning logic. Okay, and from there, any new data that I'm passing in, I'll be able to do a prediction to solve the problem. Let's look at some more examples. Okay, why this is a paradigm shift when I talk about it, I'll take autonomous cars and explain this. The whole thing that is happening now is prediction. That's what is the key. What is prediction? It is the process of filling in the missing information. I take the information I have and I'm generating the information that I don't have. That's what is the difference. One more example for you to understand this better. You all use debit card, credit cards, right? Let me take my own example. I use my credit card. Okay. Let's say I'm using my credit card in Amazon, Swiggy, Zomato, and in Bangalore, whenever I step out, I use credit cards. And usually I swipe it for 3,000, 5,000 rupees, let's say maximum. There is a pattern in my transactions. I'm sure you'll also have a pattern in the way you use it. All of us will have a pattern, right? Now, suddenly out of nowhere, my credit card is getting swiped in, let's say, Indonesia in some massage parlor. 2 lakh rupees getting swiped all of a sudden. Is this not falling out of pattern? Is this not an anomaly in a transaction suddenly? Many a times when we make some big purchases, like for example, we go to a jewelry shop and swipe our credit card for 1 lakh. Have you not got a call from your bank asking whether you are the one making the transaction? So what is happening here? It's nothing but for every individual, there is a pattern which the machine is identifying from the past data from your transactions over a period of time. And now that pattern is helping us to identify whether the new transaction that is made is done by Laxminarayanan or not, whether it is legitimate or not. It is able to identify that. Okay. So anything from the past, I'm able to decode and create a pattern, and anything that fits into the pattern is my current usage. So I'm able to predict based on the pattern that I've identified. So the new wave of AI does not actually bring us intelligence, but instead a critical component of intelligence, which is called as prediction. Take this example. Autonomous vehicles, do you think they are new to the world? What do you think? They are not. Have you seen these machines before? Have you watched Amazon documentaries? I'm sure anyone from the manufacturing space will say that, boss, we have been using autonomous vehicles for a long time. Bots moving from one shelf to the other, carrying items. 20 years, as Manpreet is saying. So bot can move, carry things from one shelf to the other, and it is all programmed, algorithmic one. As Yash is saying, lion following bots. That is, you know the factory layout. In that factory layout, the bots are clearly instructed. Follow this line. If somebody comes, stop. If somebody is, if the shelf is empty, move to the next shelf. That's how it has been working. Now, just imagine, can I consider this as an autonomous vehicle and put it on the road? Will it work? Especially Indian roads, where even if it is one way, one-sided road, one-way road, we have to look on either side to cross the road, isn't it? When humans are struggling to cross in Indian roads, just imagine if a bot is put across, it will commit suicide, isn't it? In such Indian roads. Now, how can I make, or how can I use AI to solve the problem? Can you think of a solution? Like the same bot, how can I use prediction logic or whatever that I've understood so far about machine learning, and how can I use it to solve this problem? Multiple sensors, Balan, okay. Computer vision, okay. Historical data, okay. Good, let me explain to you how this is done. Now you will understand what is the paradigm shift that has happened. Yes, I can use AI to solve the problems. How? Now all I have to do is, I have to first understand how does the human drive. If you know car driving, you know it very well. There are only 4 or 5 actions that we perform in the car. Do you agree? How do we do that? 4 or 5 actions. What are the actions? Accelerator, brake, clutch, turn right, left, all these things that we do. Now, is there a pattern to the actions that we do? Like if there is a red signal in the traffic, we have to stop. If the vehicle is applying brake in the front, we have to stop. There are patterns, right, for every action that we perform. Now, how can I capture those patterns? And how can I use those patterns to take better decisions or make a prediction? What should I do based on what is happening in the road? Simple. All I have to do is, as people were pointing out, I may put a car like this, completely fitted with sensors. And all the sensors are connected to a machine. Machine continuously captures what is happening around the car. Now, I will ask a human to drive the car now. And all the machine has to do is look all around, capture all the information, and look at what action the human is doing. Is he pressing the brake or is he pressing the accelerator? What speed he is maintaining? And is he slowing down? Is he turning right? What are the actions he is performing? Now, can I match the captured environmental inputs with the help of sensors and the actions that the human being performs, the driver performs? Can I connect the patterns between the two? Possible? To a great extent, we can map the patterns, right? Now, for every outcome, like applying brake, accelerator, or everything, Is there a way that I can decode what are the possible environmental actions which are triggering this outcome? If I do that, am I not creating an intelligent car here which can drive on its own with all the sensors used? A car which can take a decision. A car which knows how to park itself, how to drive on a road. This is what AI is all about. So what is the paradigm shift that we are talking about here then? So once upon a time, we had only one approach to solve the problems, to build intelligence in the machines. That is algorithmic way of doing things, like how the calculator works, how the fan, AC, everything works. Now, lot of problems could not be solved with this algorithmic approach. Today, we have an additional approach to solve the problems. We know that we are doing only prediction. We know that we will not get accurate answer, because prediction means it's more like astrology, right? With the help of the past data, with the help of patterns, with a certain level of accuracy, you are saying that, okay, this may happen. But still, this paradigm shift is enabling us to think of a new approach to solve the problems. Are you with me? Are you able to understand what is happening in the market today? How some of the problems which could not be solved earlier, we're able to solve them with a new approach. I'll give you some examples. Take this case, HR department in the organization. Now, how does the promotion cycle work? Or how does the recruitment work? Well, let's take recruitment. Do you all agree with me that your organization is recruiting people and there is a pattern to that recruitment? If you have worked in your organization, you can clearly tell me the pattern. What kind of a person would be a fit for your organization, correct? Now, from my past data, if I collect the data of all the people who have applied for this organization and who have been selected for this organization, is there a way that I can find a pattern of all the selected people? And then using that pattern, tomorrow, can I automate the whole process of recruitment to an extent? Are you with me so far? Are you able to understand what I'm trying to say? So hiring, I can automate, I can make it intelligent with the process. I need not just go with the criteria. I need not trouble humans to take the interviews and stuff. Promotions, I can say that, okay, this is the, let's say, for example, I am an associate director. I want to become a director. So with the help of data of the people who are already performing the role of a director, I can find out who is a successful director. And I can find a pattern for the successful director with the help of data. Now, anyone who is in the associate director level, by default, if they match the pattern of the director, can I make them a director? And as our appraisers usually say in the performance appraisal process, the moment you start performing to the next level, you'll be promoted. That's exactly what is getting automated here, isn't it? Retention. This is a project I did 6 years back for an IT company. Who will leave the organization next? I can find out. With 93% accuracy, I was able to tell my client that this person will leave the organization next with all the data collected about them. So HR as a set of predictions can be solved. Okay, this is one book I am strongly recommending to you. If you read books, check out this one, Prediction Machines by Ajay Agrawal, Joshua Johns and Heavy. You will learn a lot about how the whole AI machine learning works. If you're not a bookworm, then you can watch out videos by the same person, Prediction Machines, Economics of AI by Ajay Agrawal. It is there on YouTube. You can watch out that video. So this is what I wanted to primarily cover. I think I've completed it on time, 5:46. I would like to take some questions, but before I get to the questions, have you got a new perspective of what is happening in the AI machine learning world? Have you understood what is happening? Perfect. That's important because you have spent, yeah, it's exciting times, Vishwanath, no doubt about it. See, all I'm trying to say is the problems are still the same. How do we approach the problems? That's what is important. Today, we have got an additional way to approach the problems, and to a certain extent, we're able to solve the problems. And AI is a very, very simple technology. Let me be honest there. And by the way, AI is not even a technology. I'll be honest here. AI is not a technology. AI is a broader concept. Technology is a means of implementing intelligence. That's all. AI encompasses a lot of other subjects, like, for example, sociology, psychology, neurology. Lot of subjects are involved in AI. And AI comes together, and with the help of computer science or technology, we are able to roll out the solutions. With the help of statistical algorithms, we're able to derive insights from the data. That's how we are solving the problems. Okay, good. So if you have any questions, put it across in the Q&A chat. We have 15 minutes we can spare for answering the questions. I hope I'll be able to answer most of your questions. Good. So Justin is asking a question. Why is it that the created machine does the operation that somehow we are incapable of unless we learn how to do them? They are not incapable of, by the way, Justin. In fact, today the chatbots can speak. Chatbots can understand the language, correct? So we have to teach them, of course. Initial stuff we have to guide them, just like how kids are learning. If you have a kid at home, I'll be honest with you, if you have a kid at home, if you closely observe how kids are learning, machine learning is very, very relatable. I am lucky over the last 4 or 5 years when I picked up AI machine learning. I had a 4-year-old daughter. She was born 4 years back. I could pick up a lot of things from her way of picking up things. Okay. Good. Aisha has a question. How does AI enabled problem solving compare with design thinking based problem solving? So where empathy and human-centered design form the core principles. Aisha, it's very simple. It's a beautiful question. Have you heard of left brain, right brain, and the left, how we approach the problem solving? So design thinking is more on the creative side of thinking, creative way of solving the problem, and logical approach is another way of doing it. Now, AI machine learning comes more from the logical part. And of course, the logical intelligence that it is trying to build is from the data that is captured, and the data can be related to behavior also. Like, I'll give you one example to make you understand this. Do you know that Amazon has a wonderful algorithm that when you go to Amazon's website, within few seconds, it will find out whether you are there for shopping or window shopping? Do you know? Because we all have patterns, isn't it? On how we shop and how we do window shopping. And from the data, I can easily decode, isn't it? So Aisha, I hope that answers your question. Both are different ways of solving problems. Okay, that's a key point. Subra has a question. What are the suitable languages for AI? There are multiple languages, Subra. Python, R, Java. There are multiple languages, but I would always recommend Python as the core because of its open source support and the kind of libraries that exist to solve the problems. So go for Python if you're picking up AI machine learning for the first time. Okay. So Padma has a question. How do we calculate which mathematical model to use for a particular situation? Padma, it's I'll put it this way. How do you understand which gear is the right gear when you drive? It comes from experience, right? Of course, at a broad level, we all have this logic that, okay, for supervised problems, there are a set of algorithms. For unsupervised problems, there are algorithms. We have all these aspects. But yeah, this is something you will learn over a period of time. Okay. So Padma, you will definitely gain that from your experience. So there are some standard models also available. So check that out. So Okay, Lakshmita asks a question. I am a second year biomedical engineering student. How can I get started from scratch if I have to, if I want to pick up AI domain? Lakshmita, I will ask you to start with Python, understand machine learning concepts, and how machine learning models are implemented using Python. Try to learn that. And then try to register yourself in Kaggle. Kaggle is the mecca for all our data science experimentations. There are data sets available for you. Download data sets, explore more, learn more, practice. So 3 things I would suggest you to do. First one is prepare. The second one is project, where you can do practice. Then the third one is project. Have a strong profile in LinkedIn and in your resume, showcasing all the work that you have done. That's where your career starts. Okay, Lakshmita? Good. So how AI is helpful for students? Alok, I think everywhere AI is helpful, right? So if you can find patterns like school admissions, who will secure the best marks in the midterm or end term? I can predict to an extent. But of course, is it useful? That's a question that we may need to answer. But yes, patterns are available everywhere. Wherever you can find patterns, you can use AI. Ashok, healthcare, the best example, you can take the pharma industry, of course, allied industry, not healthcare. COVID-19 vaccinations have come primarily with the help of pattern recognitions, right? First of all, when COVID was there, we were able to identify which family it belongs to with the help of patterns, correct? What pattern COVID follows along with others. That's something we were able to decode and identify. So yes, AI as an application there. How to solve the problem of adoption of AI? See, depending on the challenges, Ashok, what kind of problems that exist. So typically, I would suggest you to hire a consultant and look at the overall challenges, the change management approaches and other stuff that will help you to fix the problem. Okay, Ranganath, for an experienced person, try to understand the concepts first, because the advantage for an experienced person is the experienced person knows how the human brain works, how we work. And all we are trying to do in AI is decode that and give it to a machine. So you can understand that better by decoding yourself and then trying to see how machines are picking up a replica of you, replica of your intelligence. So understand the machine learning concepts to begin with. You need not go hands-on, but it's more about understanding the knowledge at a higher level, how it is getting implemented. Okay, Jesse is asking, how can AI be different from cloud? AI is when both are different technologies, Jesse. Cloud is an enabler for artificial intelligence. Cloud gives you enough ROM and RAM, that is read-only memory and random access memory, that is computing memory and storage for processing all the data, which is nothing but AI. AI is nothing but using techniques to identify patterns, using statistical algorithms to identify patterns. And to do that, you need huge computational power and storage power to process the data. So Jesse, that's where cloud comes into picture. Okay, Sumit. Sumit says the data collection by a machine and learn itself is a good thing, but somehow it is a concept of, yes, there is always a conflict, Sumit, between data privacy, data security, and how it can be used. So Sumit, there is a conflict, I agree. But yes, with all those constraints also, we can do a good job with the data. So because data is available everywhere. We always say sarvam data mayam. Look around you. I'm sitting in a room. I can see my wall, which can be represented as data. The thickness of the wall, the color of the paint, everything can be data, right? So everything can be seen and everything can be resolved with the help of AI machine learning. Can we teach AI through algorithm and image pattern both? Yes, you can do that. Anonymous person, yes. Malikarjun, thank you for your kind words, definitely. Okay, so Parijata is asking this question: are prediction models and pattern recognition trying to replicate human intelligence or master human intelligence? Lot of problem solving is creative in nature, where innovation is key and not mimicry. I completely understand and accept your view, Parijata. I'll put it this way. There are always two ways of solving problems, as I was just explaining one: logical versus creative ways, correct? Depending on the situation, we choose the technique, which one to use and which one not to use. So AI can definitely be one technique in your toolkit, which you can use to solve the problem. Of course, it cannot master human intelligence. That I can confidently tell you. Okay, because finally, have this perspective. It is humans and machines who have to come together to solve a lot of problems in the society. It need not be like humans versus machines. We need not have that perspective. It won't happen also. It's only the Hollywood fiction that would create that perspective that someday machines are going to override us. It need not be the case. Together, we can solve a lot of problems. Okay. So Chetna is asking, sir, AI should also be used carefully, as I believe it relies on training, which is region dependent. AI should be used very carefully. Of course, there is a lot of bias that can creep in. So it should be created carefully. It should be handled carefully. So is it possible to put AI in microcontroller? Jawahar, not really. But yeah, AI plus microcontroller, you can look at all other applications. Maybe if you can derive some data from microcontroller observations, there you can find applications of AI. Okay. Stock market with AI, yes, there are algorithmic trading that is happening. If you have noticed, people are trying to use AI in predicting stock prices and other stuff because there are patterns again, right? But of course, you need huge volumes of data to do that. Do we have all those patterns of data? That's something which is important. Okay. Any good books for learning AI and machine learning, Mahata? I just recommended the book Prediction Machines by Ajay Agarwal. That's something you can use. So what is your suggestion to learn about AI technology for the senior management who do not work on the technical but need to take? Mallikarjun, maybe we'll connect on LinkedIn. I'll help you out. So there are a lot of broad courses at 30,000 feet level, which will help you to understand the problem solving approaches using AI machine learning. You need not get to the hands-on level. All you need to understand is when to use what. That is a question you may need answer for. And to answer that, you need basic level of technology. That's good enough. So maybe you'll connect in LinkedIn. I can help you out further on that. So how do we use IoT in traffic optimization? Justin, look at it like this. IoT is the data capturing device. Sensor, typical sensor, right? It captures data. So from the once the data is captured, when the data is captured every second, looking at the traffic and all the aspects, now start looking at using AI on top of the data. So IoT as the data source and AI as the data analysis technique. So that will help you to solve the problem. Okay. Good. I think we have answered most of the questions. I hope I can go back with the confidence that you all have learned something new today. Yeah, back to you, Amar.
Thank you, sir, for barging in between. I think we're just on time. And we've been getting such a good response. I think there were many more questions in the chat section which we have not been able to answer because of the time constraints, but we'll get back to all those questions. We'll get in touch with you, sir. We'll try and get the answers from you, and then we'll connect back with the participants who have asked those questions. And thanks a lot for your time today and for such a fantastic and informative session. If to the participants, if you have any more queries, any more questions, please feel free to drop us a mail on events@nasscom.in. I repeat, events@nasscom.in. And please also explore Future Skills Prime for more information on emerging technologies and learning content. The URL is futureskillsprime.in. With this, I thank you once again, Professor Laxminarayanan, for your time. And I'm sure participants have a lot to take with them, and lot many things that they have learned. Thank you for this session. With this, I'm signing off. This is your host Amar signing off from this session, and with a request, please stay safe and keep your masks on. Thank you everyone.
Thank you, Amar. Thank you everyone for this wonderful session. Thank you, Priya. Thank you.